How are science and technology enabling this man to pick up a shirt with a paralyzed arm? Right now on Springboard. Welcome to Springboard. I'm Rebecca Roberts. Today we're exploring the melding of man and machine, in some cases to overcome human deficiencies, but maybe someday to make average humans stronger or smarter. It's called Bionics. To get our investigation started, Springboard's Angela Morgenstern takes us to Cleveland, where doctors are researching a unique way of treating paralysis. The doctors you'll see in this piece are affiliated with Case Western Reserve University, Lewis Stokes Cleveland VA Medical Center, and Metro Health Medical Center.
You can imagine yourself one day sitting there, drawing on a drawing board or using a computer for your living, and when you can't even use your hands to feed yourself, what a dramatic change that is.
In 1974, Jim Jadich dove into a lake and hit the bottom, leaving him paralyzed with a spinal cord injury.
If I had to have one thing, I would rather have my hands back first than my legs, to where I can at least feed myself and help make a living for myself, at least help myself to where I'm not a burden, on an attendant all day.
Essentially, Jadich's brain is unable to communicate with his limbs. But for the last 24 years, Jadich has allowed doctors to experiment on him, implanting electrodes that mimic human nerves onto his muscles. To understand his story is to understand a new relationship being forged between the human body and electronics.
When a person's paralyzed, very often there are nerves and muscles that are still working, but they're not under the person's control.
The nervous system works because natural electrical pulses travel down nerves, carrying messages from the brain to the muscles.
What we're doing is rather like using jumper cables to bridge a break in the nervous system.
On these x-rays, we can see the electronic device implanted in the upper portion of Jim's upper arm near the chest. It's just underneath the skin. Outside the body is a small, portable electronic computer which can then communicate with the implanted devices within Jim's skin on the upper portion of his chest.
The first implant I had in 1986 involved using a joystick, where you had to place a joystick on the opposite shoulder of the hand you wanted to control. We now miniaturized it. You can imagine a tiny joystick inside the bones of my wrist. As I move my wrist up and down, my hand opens and closes.
When he moves his wrist, it creates an electrical signal which travels up to a stimulator in his chest. It then activates an electrode on the outside of his muscle.
How I would grab this shirt off the shelf is I hit the button on my chair that turns my hand system on. If I hit it 2 more times, that turns my tricep muscles on with my hand system. So now I am able to reach for an object, look at it, and use my arm and hand system to reach back and place the object back where it was. Now to turn the hand system and triceps off, I hold the button in, and now the whole hand system and triceps are off again. So now I'm paralyzed again.
What we see as these devices have matured is that the individual initially views them as a device or an accessory or an outside piece of equipment. But as they use it more regularly, it becomes a part of themselves.
As I got this implant and was able to grab just a normal fork like anyone else was using in a restaurant, cut my own food, feed myself, wipe my own mouth, pick up a glass and drink, I just blended in with everyone else in a restaurant. And what I'm trying to say is that helped build up my self-confidence, and I gained more independence and self-reliance to where I was going out and acting more independently around individuals, and I guess that kind of put them at ease, so everything kind of works out where we all seem to be acting normal again.
We want our people to seem normal. We don't want them to seem like very sophisticated robots or somehow an electronic person. But there are certainly other ways in which these electronic devices and these more intimate interfaces between man and machine can produce people with extraordinary abilities. For instance, the ability to see further.
I see this growing through the 21st century as we interact with the electrical control systems of the body, just as we've interacted with the chemical systems of the body through pharmaceutical devices in the 20th century.
Jim Jadich is doing his part to keep scientists on a steep learning curve. Recently, he was the first patient in North America to help test out a new interface device that allows his brain to send thoughts directly to a computer. For him, it seems 24 years as an experimental subject have paid off.
And Springboard's Angela Morgenstern joins us now. So Angela, what's the latest? How's Jim doing?
Actually, Jim has enough hand movement that he's able to make a living for himself by making mechanical drawings and sending them to clients over the internet.
Really?
So, yeah, he's doing
That's
great.
great. Now, obviously, the hand is a very visible victim of paralysis and something that you can see the treatment for. Are there other sort of behind-the-scenes applications for this electrical stimulation?
Right, Rebecca.